This is an interesting problem in friction and uniform circular motion. Let us read the question. A stunt cyclist rides on the interior of a cylinder 12 meters in radius. The coefficient of static friction between the tires and the wall is 0.68. Find the value of the minimum speed for the cyclist to perform the stunt. Here is the cylinder. And then I am taking the object, the cyclist as the point object and representing it as a dot. Okay. And the forces the forces acting on the object are represented here in a free body diagram. The cyclist weight is acting vertically downwards, that as Fg, and then the frictional force acts in the upward direction. And then the applied force, the cyclist applies the force on the cylinder. That is why that force is applied force acts on the walls of the cylinder. And then the normal force opposite to the applied force directed towards the center. Center is somewhere here. It may be a bit difficult for you to visualize this kind of forces because in general, you come across forces as like this, some object lying on the table or somewhere, and then the weight acts vertically downwards, and then Fg acts vertically, Fn acts vertically upwards. Okay. This is Fg, Fn. And then if the object moves towards right with some acceleration, then the friction will be in this direction. F friction will be in this direction. This is the general representation of the forces you come across in your study. But here, everything is upside down. Instead of horizontal direction, the friction is acting in the vertical direction. And then the normal force, instead of acting the vertical direction, it is acting in the horizontal direction. So I will explain this concept with an example. Here is an object. In general, what happens is, suppose if you press an object towards a wall, okay, the applied force is acting towards the wall, and then the opposing force is the normal force acting towards the or against the applied force. And then the weight of the object acts vertically downwards. And if the applied force is removed, what happens? The object slides down and then falls on the floor. Okay, so the friction is the one which is keeping the object not to slide. So the friction is acting vertically upwards. The same analogy holds good here. Okay, so see the forces, representation of the forces here. Weight vertically downwards, applied force towards the wall, and then normal force towards the applied force. Okay, and then friction upwards. So weight and friction are balancing each other. Applied force and normal force are balancing each other. Okay, and the object is a static equilibrium. Same way here, the weight and the friction are balancing each other, and then the normal force and applied force are balancing each other, and the object is in static equilibrium. And here, the normal force is acting towards the center, so the normal force is called the centripetal force. You know, to negotiate a curve or to keep an object in a circular path, centripetal force is required. Here, the normal force acts as the centripetal force. Generally, either tension or the gravity or friction or the normal force, any kind of force act as the centripetal force. Centripetal force is not a new force or a force which comes all of a sudden from nowhere. Okay, it is just any of the forces you studied in your regular study acts as the centripetal force. The only thing is the force is directed towards the center. That is why we call it as centripetal force. So here the normal force is the centripetal force. Now let us represent the forces, write the force equations. What are the forces acting in the y direction? Fy is equal to F friction minus Fg is equal to 0. Because the object is in static equilibrium, the forces are balanced. Okay. Now, what we have to do, we have to, therefore F friction is from this equation, F friction is equal to Fg. Okay. Now you know F friction is equal to, frictional force is equal to mu Fn. Okay. And then here, Fn is directed towards the center. Fn is equal to Fc, centripetal force. Fc is the centripetal force. Okay. And you know Fc is equal to mv square over r. Therefore, what I do is here F friction is equal to, I substitute Fc value here. Instead of Fn, I will write Fc. Okay. And then Fc is equal to mv square over r. That implies F friction is equal to mu mv square over r. Okay. And then F friction is equal to Fg, and then Fg is equal to mg. Therefore, I will write F friction is equal to mu mv square over r is equal to mg. And m cancels out, and then we are left with v square is equal to rg by mu. R v is equal to square root of rg by mu. R v is equal to, let us plug in the values. R is 12 meters, and then g is 9.8, and then mu is 0.68. This gives the value 13.15 meters per second. Therefore, v is equal to, we will round off, v is equal to 13 meters per second. Is the answer. Okay. Here, the simple thing is you have to identify the forces. Identification of the forces is all the more important, and afterwards writing the free body diagram. Okay. If you do that one, then the problem is very easy. You never expected that the normal force acts in the horizontal direction and then friction in the vertical direction. That is the complicated part in this problem. If you know this analogy, or if you remember this analogy, you can easily make out the friction can also be in the perpendicular direction, and then the normal force can be in the horizontal direction. Okay. And moreover, normal force can also be the centripetal force, because the normal force is directed towards the center. That is why it is called the centripetal force. If you are able to recognize, or if you are able to understand this concept, this problem will be very easy for you to do. Okay. I hope this helps. Thank you. Bye-bye.